In this video, we will consider other CAD cycle, which is G82 counter boring cycle. Counter bore is used to enlarge the top of the hole for many reasons. One of the reasons is to have head of the bolt not projected above the surface. So to avoid any bolt or any washer or any projection above the machined surface, so we enlarge the hole. So counter bore required initially a drilled hole, and afterward that we use that type of counter bore tool to enlarge the hole. The CAD cycle G82 is very similar to the drilling cycle G81, except only two differences. The first one is that dwell time. The second one is the number of repeats if required. Number of repeats means the same CAD cycle will be repeated so many times based on this number. The mechanism of doing G82 is to bring the tool, then doing the process, which is counter bore, then dwell time, then retract. When we retract, either to retract to the R level using G99 or to the initial or safe level using G898. Let us apply this counter bore cycle in one example. This is the example we have. This is a zero coordinate system, X and Y and Z. This is a workpiece where we have 4 holes already drilled and ready for counter bore, and these are symmetrically located at distance of 0.5 from the y-axis and 0.5 from the x-axis, and the same distance for other holes. So it is symmetrically distributed along the workpiece. We start by selecting which tool we're going to use. Then we use absolute coordinate system, and one of the coordinate system which we select is G54, which is system number 1. G00 rapid movement to that position. Let us see what this value represent. Let us link this value with the geometry of the workpiece we have. X.5, this is the coordinate system, X.5, Y minus 0.5, so this is the location. So we bring the tool to that first location. Then we select the speed, whatever convenient speed based on the tool material and the workpiece material and accuracy and the quality requirement. Then we use G82. Here we use with G82 G99. It means when we retract it, we will retract it to the R level. Why Z is negative? Z is negative here because this is a 0 point, so any negative value means in that opposite direction. This is what we require to counter bore in that direction. Why this amount? Because this is the depth of counter bore as being given here in the geometry of the workpiece. We select the R level on the top of the workpiece surface deviated by 0.1. This dimension is in inch system. And this is the recommended feet based on the workpiece specification and the material of the tool as well. The next will be to shift the tool from that position to that position. What we just need to program what is the new value of x, because y is the same, so no need to mention y here. So when we select x equal 1.5 means we move the tool to that position, because that location is 1.5 from the 0 point. What it means, as we mentioned before, any candy cycle is a model cycle. Model means once it is the tool and the spindle is moved to a new position, it will create the same cycle again. So when the tool moves to 1.5 from the 0 point, it will repeat that block again, similarly the same, because G82 will be active here as well. What is next? What is next is to move the tool to that position. Once we finish hole number 1 and the process number 2, we go for number 3. So what change we do here? X will be the same, so no change in X. So that we concern about the value of Y. What is the value of Y? In that case, it will be minus 1.5. So that's why Y here is minus 1.5. And again, just to mention the new location, by the specification or the configuration or the characteristic of the candy cycle, it will be repeated again at that new location. The final location will be that position. That position, it has the same value of Y. So here we only change X. So X will be now the new X, which is 0.5. Again, the same at this position at X 0.5, and at the same Y, the counter bore candy cycle will be repeated at that position as well. So this is the end of the program, and we just retract the tool to a safe position where Z is equal 1 above that point. So 1 means in that direction is positive value, and we terminate the candy cycle by G80. Otherwise, it will remain active. It will still active, and we end the program. So this is a typical example of using that type of candy cycle. The next cycle will be another cycle, G83. What is G83? G83 is a deep or big drilling candy cycle. What is the meaning of deep or big drilling candy cycle? Whenever we have a hole depth equal or greater 3 times the drill diameter, we consider it as a deep hole. In that deep hole, it needs certain treatment to prevent the chip from backing or clogging in the drill flutes. If it happens, it will result in breakage of the drill, and it will render the flow of the chip, and it will also render the delivery of the coolant to the cutting point of the tool. And also the candy cycle G83, again, this is the format of this candy cycle. The only difference here is Q. What is Q in this case? Q is the depth of cut for every cutting feet. Depth of cut, so we do so many cuts. It will be created in multiple cuts. Every cut will be programmed with this amount of depth. So when we select 0.25 or 0.25, it means every big will create that amount of length till the total depth of hole is completed. So again, we can associate with the G83 either G98 or G99, and this to bring the tool to whatever location. And this is the depth of the total depth of the drill, but this total depth of the hole will be done in a series of picking and every pick will be with this amount, and the R is the R level above the surface of the workpiece. So this is the configuration, or this is the explanation of that picking cycle or deep picking drilling cycle. F is the cutting feed rate. And again, we might, some controller allow key again similar to G82, but we don't consider it here. If we consider K, it means the number of repeated that drilling might be repeated, or that cycle may be repeated so many times. Let us see a schematic diagram of that process, how it looks like. This is if we use G98, and this is if we use G99. The only difference is 98 will be retracting the tool to the initial level or the safe level, and G99 to the R level. This is the R level, just above the surface of the workpiece. And this is sketch indicating how the picking cycle is done. First of all, we do a first pick, and the amount of Q as you program as you like. In the previous example, it was 0.25. So the amount of feed will be 0.25, then retract. Then another pick, adding another 0.25, another Q. This is another Q. Then retract. Then again another Q. Then retract. So we do, of course, that will be done on the same line. This is just shifted for explanation, but of course it is done on the same straight line according to the location of the hole. What is the difference here? Look at the difference here. The only difference here is the final retraction. This is the final retraction. We retract the tool to the initial level. Here the final retraction retract the tool to the R level. So this is the only difference. As you see again, this is solid line indicating feed movement, and this is a dot line means fast movement. So as you see here, the feed movement, the cycle by itself will be done like this. So the feed movement will start a little bit before the actual bit depth. It is to allow a steady starting of the cutting tool to do that process. The next is the tapping CAD cycle. Tapping means creating internal thread in already drilled hole. So we use a tapping tool. This is a tapping tool, and this is G84 for that cycle. When the bottom of the hole has been reached, when the tool reaches the bottom of the required depth, the spindle will rotate in the reverse direction. It will reverse its rotational to follow the thread which created in the downward pass. So during the upward pass, the tool has to reverse its direction, otherwise it will damage the already created thread. Again, this is 98 and this is 99. The only difference exactly as we mentioned before. Let us see the animation of that type of CAD cycle, which is G84. This is animation. We start bringing the tool to that position, XY location, and whatever the R level, what is the amount of R level, and whatever the final Z, the final depth of cut, and whatever the feed. Here the feed should be calculated, not selected. Calculated based on what? Based on the pitch of the thread. So first of all, the cycle will create rapid movement to the R level. So the tap will move, the tool will move with rapid movement to that level, as we see in that animation like this. Yes, like this. So this is a rapid movement to R level. No feed movement. This is a rapid movement here. Then the next step, feed to the Z level. The movement from the R level to the Z level will be with the amount of feed rate, which is the pitch of the thread, like this. Then it will reverse. So this is the movement with feed movement to the Z level. The next, the tool will retract, but before it retract, it will reverse its direction, and then it will retract feedback. When it retract again, it will retract with the same amount of feed. It will not be a rapid movement. It will be again a feed movement. And the retraction either to the R level or to the initial level, based on what? Based on if we use 98 or if we use 99. So that feed and that speed are related. The speed of the tool and the feed of the tool. Speed is the rotational speed, and the feed is the axial or the linear speed. So that has to be considered to create the same pitch of the thread. Let us see how we can calculate that. So let us see how we synchronize the speed and the feed in that process. So before we starting this process or creating this program or writing this G-code program, we have to know the tapping speed and accordingly calculate the tapping feed. Tapping speed is based on the tool and workpiece material and the thread configuration. Assuming that we have this type of tap, half-13. What it means? It means this is the size of the thread in inch, and this is TBI. TBI means teeth per inch. So if we know that if we have 1 inch, in that 1 inch we have 13 teeth. So what will be the pitch? The pitch will be 1 inch divided by 13. So that will be the pitch in inch of the thread. Now we have two systems of programming the speed, either to use feed per rotational, feed per rev, or feed per minute. So if we program using feed per rotational or per revolution, we should use G95. To program in feed per minute, we should use G94. So assuming we start by bringing the tool to whatever the location of the hole and knowing the depth of the hole and collant on, M8 collant on, then if we use G95, it means we will program in feed per rev. So if this is the speed, 1000 revolution per minute, so in that case, our feed will be the same, is equal to the pitch, because here it will be per rev. The feed will be per rev, and the rev is the same as this one. So this is a typical application of if we use G95. What if we use G94? Here we use G94 and we use the same speed. In that case, it will not be feed per rev, it will be feed per minute. How to transfer this feed from feed per rev to feed per minute? By multiplying this amount by the amount of rev per minute, which is 1000. So we multiply this by 1000, so it comes like this. So this is the difference between using feed per revolution or feed per minute. So we can summarize this process again. First of all, we have to know what is the specification of our thread. Our thread diameter is 1/2. and the number of teeth per inch is 13. Based on that, we can get the pitch, 1 inch divided by 13. Then we ask ourselves which system of speed we're going to use. We're going to use feet per revolution or feet per minute. If we use feet per revolution, then we use this amount as the feet. If we use feet per minute, then we multiply this amount by the whatever speed we have. For example, if we apply this, on this example, if we are doing a metric thread, now it is not an imperial thread, it is a metric thread. Metric thread is given directly the pitch. So this is the pitch. We don't have to calculate the pitch as we did before. So this is the metric thread. The diameter is 10 and the pitch is 1.5. Suppose this is our speed, and suppose we're going to use G94. 94 means feet per minute. So in that case, how we can program our feed? Our feed will be programmed by multiplying that feed by the amount of revolution. So 1.5 times 60, it will be 90. So in that case, that will be the amount of feed of programming. We can, of course, we can apply all so far can recycle either G81 or G83 or this tab cycle, which is G84. We can apply all this to a typical case or a typical example we have here. We have actually we have a workpiece. This is a workpiece, and we have different group of process in that workpiece, starting from number 1. This number here is number 1, number 2. This is the first group, and this group has this configuration 38-16, 2 holes. What it means? It means every one of these hole has a dimension of a tabbing with this diameter, and this is the TPI or teeth per inch for these particular 2 holes. It is 2 holes. So the first group have this requirement, and they are located at this amount from the edge, the lower edge of the workpiece, and the space between the 2 holes is 1 inch. The second group, which is hole number 3 and 4 and 5 and 6, they are circular, located on a circular pitch, and the pitch circle is 2 inch. It means that circle diameter is 2 inch, and the center of that circle is located at 2.5 from that edge and 2 from that workpiece edge. So we know the location of the central pitch, and we know the diameter of the pitch, and these holes are diagonally located along that pitch. What is the configuration of these holes? Again, it is very similar to that one. It is the same like this one, but it is 4 holes instead of 2. So it has the same requirement. What about the third group, starting from hole number 7, 8, 9, 10, up to hole number 11. So this is the third group. It is 11 equally spaced hole. This number of holes, they are equally spaced hole. Equally spaced hole. The same distance. It is located along with the same distance. And what about the configuration of this hole? They are the same, like this 3/8, 16ths, and they are the first hole located from that edge by 1 inch, and the line is located from that edge by 2 plus 2, 4 inch from that edge. So this is a typical application. First of all, we have to drill these holes first. All this hole has to be drilled. then this group will be tapped and this group will be tapped. However, this group will be tapped and the counter board. You see here, this group, this group, it should be counter board. After, so it needs drilling, it needs tabbing, and it needs later on it will require that counter board. So we apply here 3 CAD cycle in that application or in that example. So I recommend to go through that example and do programming for that example to apply whatever we learned in that video. Thank you and see you next time, inshallah.